Hello everybody! Today and tomorrow, so the 2-day lesson, I can solve compound right triangle problems using subtraction method or reflexive method and using Sohcahtoa and Pythagorean theorem. So all these questions are going to be 4-point questions involving right triangles. They're going to all be 2 steps, and the majority of them are going to either be what I call subtraction method or reflexive method, although there will be some other methods as well, which we'll kind of talk about as we go through. So you do need to know how to do Sohcahtoa and Pythagorean theorem to be successful in this lesson. So if you do not know how to do Sohcahtoa or Pythagorean theorem, go back to those lessons and learn that first, because we're going to build off of that. So these are basically our 2 procedures, subtraction method and reflexive method. For subtraction method, we're going to find corresponding parts of the 2 triangles and subtract them. We're going to start with that. I'm going to show you what that means. As shown in the diagram below, a ship is headed directly toward a lighthouse whose beacon is 125 feet above sea level. I see that 125 is in the picture already, so that's great. At the first sighting, point A, the angle of elevation was 7. Great. That's in the picture already. Later it was, 16 was here, 7 was there. Those are both in the picture. And it's asking for how far the ship traveled from point A to point D. So it's asking for that. So here's what I see. I see 2 right triangles. I see this right triangle. I see this right triangle. The first method I want you to look for is subtraction method. Is there anything I can subtract in order to find that missing piece? And the answer is yes. If I find this whole bottom side of the big right triangle and I find this bottom side of the small right triangle, I can subtract those to find that missing piece. So that's exactly what I'm going to do. I'm going to separate my triangles to make this a little bit easier. So my big one is A, C, I don't even know what letter's up top there. There is no letter up top there. That's just my lighthouse. So I just won't give it a letter. And then the 125 is the height, and the angle is 7 degrees, and I'm going to find this side. And then separately, I have my small triangle, the lighthouse, that is still 125. The angle here is 16 degrees, and I'm going to call this Y. And now I'm going to do Sohcahtoa for each of them. So I'm going to label my H, my A, and my O. Out of the A and the O, which 2 are A, O, and H, which 2 are involved? A and O. So I'm going to use tangent. Theta in this example is 7. O is 125. A is X. Because I'm finding a side, I'm going to be cross multiplying. So let's turn my calculator on. There we go. So let's make sure I'm in the proper mode. Yes, I'm in degree mode. So I'm going to type in tan 7. I'm going to get 0.1227. .1227 ... equals 125 over x. I cross multiply and solve. 0.1227x equals 125. Divide by 0.1227. And I'm not just dividing by 0.1227. I have stuff after that. So I'm going to do 125 divided by, and I'm going to copy and paste that. 1018. I'm not going to round that either. I'm just going to put 1018 dot dot dot. Now I want you to do the same procedure for the green triangle. So why don't you pause it, do the same procedure for the green triangle, then unpause it. Okay, now that you did the calculation for the green triangle, I'll go over that. H, A, O. O and A are involved. So again, it is tangent. Tangent of theta equals O over A. Theta is 16, O is 125, A is Y. Tan is 16. I put that into my calculator. I got 0.2867 dot 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 equals 125 over Y. Cross multiply. 0.2867Y equals 125. Divide by 0.2867 dot dot dot. Y equals 125 divided by, copy and paste that. I get 435 dot dot dot. So if this whole thing is 1018 and this piece is 435, to find my missing x piece, I can do 1018 dot 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 minus 435 dot dot dot. That will give me my answer. Again, those dot dot dots means I'm not subtracting 1018 and 435, I'm subtracting the whole long decimal. So I'm going to tab up so that the 1018 point whatever is highlighted, hit enter, minus tab up so the 435 is highlighted, hit enter. Now that I'm done, I'm at the very end of the question. It's asking to the nearest foot, so now I can round this answer to 582 feet, and that's my final answer. So it might seem like a long problem. It is a long problem, but conceptually it's pretty straightforward. To find the distance from A to D, I'm looking to see if there's subtraction, and yes, if I find this whole piece and I find this piece, I can subtract them to find the missing piece. So I set up my two right triangles, I find that bottom side for each, I got 1018 and 435, and once I had those, I then just subtract them to get my answer. It's a very commonly asked Regents question, and if it's practice, it's really not bad. So number 2 is very similar. Let's get started with it. Angle CAD is 25. ABD is 42. AD is 60. And it's asking for BC. Well, I see two right triangles. I see this small one. And then I see this big one. Can I use subtraction? Yes. If I find this whole piece and I find this piece, then I can subtract them to find my answer. So I'm going to give you a choice. You can pause it, try it on your own, and then unpause it, or you can follow along with me depending on how comfortable you are after seeing that first example. So if you want to try it on your own, pause it now. Okay, so at this point, either you try it on your own or you just want to see another example gone over. Either way is fine in this particular case. So my green triangle is ADB. This is 60, this is 42, and I'm trying to find that. My blue triangle is CDA. This angle is 25. This is 60. I'm trying to find that. Sohcahtoa. So for my green, HAO, which two are involved? A and O, so it's going to be tangent. So tan of theta equals opposite over adjacent. Tan of 42 equals 60 over x. Tan of 60, put that into the calculator. 1.7320 equals 60 over x. Cross multiply 1.7320 x equals 60. Divide by 1.7320. And I get x equals 34 ... And now I go on to my blue one. HAO, A and O are involved. So again, I'm using tangent. And yes, on these subtraction method ones, it's usually going to be tangent, but not necessarily. Tan 25 equals opposite is y over adjacent is 60. I'm going to go to my calculator for tan of 25. 0.4663 equals y over 60. Cross multiply. This one's going to come out a little bit different. I'm not going to have to divide here. I'm multiplying the 0.4663 times 60. So 60 times, copy and paste that. I get 27 ... So the green one was 34 ... The blue one was 27 ... So to find this missing piece here, I'm subtracting the 34 and the 27. I'm just going to copy and paste what's in here. There's my 34 minus, there's my 27, and I get that. It wants me to round to the nearest tenth, so that's 6.7. And that's my answer. So again, it's kind of long. It's a 4-point Regents question, but it's pretty straightforward. To find that missing piece, I'm going to have to subtract the two bigger pieces. So I use Sohcahtoa twice to find those two, the big piece and the small piece, and I subtract them. Now, number 3, there's no picture, so I'm just going to help you set up the picture, but beyond that, I'll let you do it on your own. There's really 2 ways to do this picture-wise, and let's kind of just start. Frida, who is training to use a radar system, detects an airplane flying at a constant speed and heading in a straight line to pass directly over her location. So here's option 1. Here's Frida. There's an airplane, and it's flying, so it's going to end up straight overhead. She sees the airplane at an angle of elevation of 15 degrees and notes that it's maintaining a constant altitude of 6250. So the altitude is 6250. And the angle of elevation is 15. So that's where the plane is here. It's a really bad plane, but whatevs. 1 minute later, she sees the airplane at an angle of elevation of 52. So now the plane has traveled. These are kind of the wings, the tail. And now it's at an angle of 52. How far has the airplane traveled? And it's basically the same thing we had before. Now, the other way you could have set this up, the first situation, either way, the altitude 6250. The first one had an altitude of 15. The second situation, again, the altitude was 6250. Now it was 52. And again, you have to understand, you have to find each of these and subtract them. So either way, that's how you'd set it up. And you're going to have to use subtraction again, because in order to find this piece, I can do this minus this. I'm not going to do this for you. You can try it on your own from here. I'm going to move on. I'd like you to come back to that. I just wanted you to see the setup. Now, number 4 is similar but different. It's giving you the picture, which is great. It's asking for this angle. Well, can I use subtraction method? Yes. This angle would be this whole angle, which is an angle of the big right triangle, minus this angle, which is the angle of a small right triangle. So I'm going to have to find the angle of the big right triangle, the angle of the small right triangle, and subtract them. So, Sohcahtoa. I would like you to try this on your own. It's the same procedure, but now we're not going to be finding a side, we're going to be finding an angle, which you should know how to do. So again, I would like you to try it on your own. So please pause, try it on your own, and then unpause. Or if you feel lost, then you can just watch this example. Okay, either way, at this point, I'm going to go over it. So our blue triangle, 60, 75, and we're finding x. Our green triangle, 12. Actually, I think I made a mistake. 75. I'll call this y. Let me just. All right. No, the big triangle is not 60. The big triangle is 72, because you have to add that 60 and the 12. So, 72. H-A-O. H-A-O. In the first one, O and A are involved, so it's going to be tangent. Tan theta equals O over A. Tan x equals 72 over 75. I'm also going to set this one up at this point. So again, tan theta equals O over A. Tan y equals 12 over 75. Because you're finding the angle, you're doing inverse. X equals inverse tan of 72 over 75. Y equals inverse tan of 12 over 75. I go to my calculator. I'm going to type in inverse tan, second tan of 72 over 75. And then I'm going to also type in inverse tan of 12 over 75. So that's 43 and 9. So if this whole thing is 43 and this little piece is 9, to find this missing angle, I'm going to do 43 minus 9. Again, not just 43 minus 9, but the whole long decimal. 43 minus 9. And I get to the nearest tenth of a degree, 34.7 degrees. So this one is the same concept as the ones we just did. We're going to have to find a corresponding pair of something from the two triangles and subtract them. You might have to find sides, you might have to find angles, but if you can subtract two pieces of the two triangles, then that's what you're going to do. Now, number 5 is going to be a different method, and you'll see why as you go through here. So the good news in this problem is that it gave us a lot of information. It gave us a picture, and it looks like most of the information's in the picture already. The map of a campground is shown below. Blah, 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 blah. The length of FS is 400. That's in there already. The angle formed by TF and FS is 72. That's in there already. The form passed by TC and CS is 55. That's in there already. Determine and state the distance from the campsite to the tower. Campsite to the tower is this right here. So, will subtracting anything give me that side? No. Subtracting, there's nothing to subtract. It's not a big piece minus a small piece, so that's not going to help us here. Right now, that's a side of the big right triangle. Do I have enough information in the big right triangle to do either Sohcahtoa or Pythagorean Theorem? Well, all I have right now is this angle. So, no, I can't find it right now. So what I'm going to use is my reflexive procedure. Is there a side that's in the small right triangle that's also in the big right triangle? Yes, this one. Do I have enough information to find that side? Yes, because I have an angle and I have one of the sides. Once I find that side, then I'll have enough information to use the purple triangle. So we want to find a side or an angle that's in both triangles, find it for one of them, and then that piece of information I'll be able to use in my next calculation. So I'm going to start with my green triangle because that's the one I have enough information to do something with. 72, 400, Y. H, A, O. O and A are involved, so it's going to be tangent. Tan theta equals O over A. Tan 72 equals Y over 400. Calculator, tan 72. And listen, if you want to do these calculations on your own, go for it. You can feel free to pause. 3.077 equals Y over 400. Cross multiply and solve. I'm going to get Y equals 400 times that long decimal. Copy and paste it. I get 1231. So this is 1231 ... Now that I have that, I have this angle is 55. I'm trying to find this, and now I know that this is 1231. So H, A, and O. Out of the A, the O, and the H and the H are involved, so it's going to be sine. All right, I feel like we've seen only tangent, so it's good to see something different. Theta is 55, opposite is 1231, hypotenuse is x. Sine of 55. Sine 55 is 0.8191. A lot of dots going on here. Cross multiply and solve. I'm running out of space. 0.8191 ... x equals 1231. Divide by the 0.8191. So be careful here. I'm doing the 1231 divided by the 0.8191, and I get 1502.86 whatever. To the nearest foot, that is 1503. And that's the answer. So again, we talked about subtraction procedure and reflexive procedure. If I can subtract two things, then that's what you're going to do. If not, you want to look for a reflexive side or angle, a side or an angle that's in both. And if you have that, then that's what you want to do. Find it. Once you find it from the small triangle, because you had enough information in the small triangle, you use that piece of information in the big triangle. Okay, so let's take a look at the next one. Number 6. Don't think I need this picture quite this big. Find the measure of angle PCA in the diagram of right triangle TAO to the nearest tenth. Well, subtraction. Is there anything I can subtract to find this angle? No. This angle is in this right triangle. Do I have enough information right now to find that? No. I just have one side. I would need some other piece of information. So now I look for reflexive. Is there a side or an angle that I can find in both of these right triangles? The answer is yes. This one. So I can find that in the big right triangle and then use that to find the small right triangle. So here's my green, TAO, that's Y, that's 82, that's 30. Please pause, find that missing side labeled Y, and then unpause. Okay, now that you've found this missing side, I'll go over it. HAO, H and O are involved, so it's sine. Sine theta equals O over H. Sine 30 equals Y over 82. Sine 30 is 0.5, one of our very few nice numbers that we get. Cross multiply and solve. I get Y equals 0.5 times 82 is 41. So, since this is 41, I can now go to the purple triangle, TAC. I'm trying to find this. I have that this is 36. I have that this is 41. So I'm sorry. At this point, I want you to find that missing angle on your own. So please pause, find the missing angle on your own to finish the problem off, then unpause. At this point, you should have calculated that angle, so I'm going to go over it. HAO, A and O are involved, so I do tangent. Theta is x. O is 41. A is 36. Because I'm finding the angle, I do inverse. X equals inverse tan of 41 over 36. So I hit second tan of 41 over 36. And to the nearest tenth of a degree, I get 48.7 degrees. So reflexive, if I can't subtract to find it, and I don't have enough information to find it, when I have overlapping or compound right triangles, I find a reflexive side. This side is in both. I could find this side using the big right triangle in this case, because I have enough information to do that. And once you find it, then you can go to the triangle that contains the piece of information you're trying to find. And now that you have enough information to find it, you find it. So 7 is pretty much the same thing. I'm going to skip past that for now, which brings us to number 8. Now these aren't quite reflexive or subtraction. It's kind of just figuring it out as you go, taking it one piece at a time. So I will go over this question, making it a little bit smaller so you have more room to work. And we're going to kind of go through this together. As modeled in the diagram below, an access ramp starts on flat ground and ends at the beginning of the top step. Each step is 6 inches tall and 8 inches deep, and you can see that that information is given to you in your diagram. The angle of elevation of the ramp is 4.76 degrees. So this is the angle of elevation. Determine and state the length of the ramp to the nearest foot. Well, it says that this is the ramp. This is what we're trying to find. So, let's see. Well, I need another piece of information here. I don't have enough information to do it because I just have one angle. I'm trying to find a side, so I need another side. Well, I'm looking at this side. If this is 6, this is 6, and this is 6, so think of it this way. This is 6, this is 6, this is 6, so this whole slide is 18. So it might help to kind of draw a new picture without all the extra stuff. This is 4.76, this is x, and this is 18. 18 inches, by the way. So, we can find it. I want you to pause. I want you to find that on your own. Okay, now that you did it on your own, I'll go over it for you. H-A-O. O is involved, H is involved, sine. Sine theta equals O over H. Sine 4.76 equals 18 over x. Go to your calculator. Sine 4.76 is 0.0829. 0.0829 ... x equals 18. I am totally out of space here. Sorry for the sloppiness. It is what it is. I get x equals 18 divided by, copy and paste that, 216 ... However, that's inches. It wants it in feet, so I can just divide it by 12 since there's 12 inches in a foot. You could have done the conversion at the beginning as well. Either way is fine. In my answer key, I might have done the conversion at the beginning. and I get 18.1 feet. So this is 18.1 feet. All right, now there's another question. Determine and state the nearest tenth of a foot, the horizontal distance d from the bottom of the stairs to the top of the ramp. Well, d is part of this side. And since this is 8, this is 8, and this is 8, this is 24 inches, or I'm just going to convert it now. So, and say, let's keep it as 24 inches. No, I'm going to make it as 2 feet. And this 18, I'm going to rewrite as 1.5 feet. Because if I divide 18 by 12, I get 1.5. So let's forget about the 2 feet. I know that this is 1.5. I know that this is 18.1. I know that this is 4.76. I want to find the bottom. I'm going to call this y. Now you have a couple of options here. You can use Pythagorean Theorem, or you can use Sohcahtoa. Since I have the two other sides, I have enough information to do Pythagorean Theorem, so let's do Pythagorean Theorem. I haven't done it yet today. So y squared, let me just make this bigger, plus 1.5 squared equals 18.1 squared. So I need to do 1.5 squared and 18.1 squared, 1.5 squared, and then I'm going to take this whole thing and square it. So I've got y squared plus 2.25 equals 326 minus 2.25 minus 2.25, running out of space again, y squared equals minus 2.25. And by the way, instead of copying and pasting, if I just hit minus, it takes the previous answer and it just copies and pastes it automatically. Square root of both sides. Second radical, copy and paste that to the nearest tenth of a foot. That is 18.0. And that's your answer. All right, so it's definitely a long question, but you know, it's 2 steps. These are, if you see a 4-point question, it's going to be 2 steps. The little twist here is you have to deal with these inches and all that. I'm sorry, that's not the correct answer. That's 18.0. Because it wants the distance d, I need to subtract off this 2 feet. So the 18.0 minus 2 is 16.0. And that's your final answer. So let's kind of take the circle off this one. So there's definitely a lot going on there, but you know, it is what it is. I don't know why I'm circling again. I'm getting a little messed up on space. And this is why I always say, don't cramp yourself. So when I solve this, I got y equals 18.0. But again, that's the whole bottom. I have to subtract off that 2 feet, because 24 inches is 2 feet, to get 16.0. And again, you know, it is what it is. It's got some challenges, but you just have to start, find something, deal with these inches, and, you know, deal with whatever they throw at you. Number 9 is I'm not going to do it for you on your own at this point. You know, I want you to start trying things on your own. It's similar, but it's different to number 8. You have to kind of come up with your own plan, so I want you to try that one on your own. I'm just going to go over one more with you. I'm going to go over number 11. And then the other ones that we didn't do, you know, you can do on your own. You can use my key to help you do it on your own. But, you know, I know they're a little tricky. They're not as easy as some other lessons. But at a certain point, you have to start trying them on your own. Kira has a square poster that she is framing and placing on her wall. The poster has a diagonal 58 centimeters long. That's in the picture already. The width of the frame is 4. Determine and state the total area of the poster and frame to the nearest tenth of a square centimeter. Well, the area of a square or a rectangle is length times width. So I need to find the length and I need to find the width. Within this picture, I see a right triangle. If I can find the sides of this right triangle, then I can find the sides of the big square. And these are all squares we're dealing with here. It says it's a square poster, so everything's a square. So if I can find the sides of this square, then I can find the sides of the big square. So since this is a square and all the sides are the same, I'm going to call them both x. It's a right triangle. There's no angle involved, so I use Pythagorean Theorem. A and B are x and x. The hypotenuse is 58. X squared plus x squared is 2x squared. 58 squared is 3364. $33.64 divided by 2 is 1682. Square root second radical 1682 41 dot dot dot. So 41 dot 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 41 dot dot dot. Since the width of this frame is 4, then that's 4 and that's 4 and that's 4 and that's 4, which means this whole thing is going to be 4 plus 4 plus 41. So it's going to basically be 41 plus 8, which is going to be 49 dot dot dot, and the same thing here. So now to do my area equals length times width, it's going to be 49 dot 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 times 49 dot dot dot. So in my calculator, I just need to add 8 to this thing, and then I'm essentially just squaring it. But if that's confusing, I'm just going to do my 49 times my 49 to the nearest tenth of a square centimeter. That would be 2402.2. Again, these questions I would not say are easy. I think they're definitely challenging, but you just start with something. In this case, I see a right triangle. I could find a missing side using Pythagorean Theorem, and once I have that, I can kind of do a little bit of simple math to find the sides of the square and find the area by doing length times width. For something like this, I just started with what they gave me. I had to deal with those steps and those inches. I added them together to find those missing pieces, and from there I did a compound right triangle problem. With general overlapping compound right triangle problems, we have two methods. We have reflexive and we have subtraction. In this case, it was asking me to find this angle, so subtracting is not going to help me, so I look for reflexive. I look for a side that's in both triangles. This side was in both triangles, so I found that side using the other triangle, and then once I had that information, I could find what I was looking for. And again, the first thing we did, when I see overlapping right triangles, I look to see if subtraction is going to help me. And in this case, since I'm looking for this, yes, subtraction is going to help me. If I find this whole side and I find the smaller side of the smaller right triangle, I can subtract them to find the missing piece. Again, not the simplest lesson in the world. You need to have Sohcahtoa down, and Pythagorean Theorem is a prerequisite. And this is a very commonly asked 4-point question. So it is important that you're able to do it if you want to do well in the geometry regions, and it just takes practice. It takes practice, and of course, you need to be comfortable with Sohcahtoa and Pythagorean Theorem coming into it. Your classwork/homework is to practice and finish this, and I hope everybody has a great day.